let's look at an SN2 reaction, and I've chosen a simple SN2 reaction to start with. This is methyl chloride. I've just colored my hydrogens differently and the chlorine differently so that we can keep track of things. And we're going to react this with Br minus, bromide ion. And we know from the things that we've talked about before that the Br minus is going to attack and the chlorine is going to leave, or the chloride is going to leave at the same time, because this is an SN2 reaction. And one of the things we always talk about with an SN2 reaction is that the nucleophile, in this case the bromide, will perform backside attack on the reactive center. And what that means is the Br minus comes in from one side and the Cl leaves from the other side. If we look at a three-dimensional model of that, it would look something like this, where this is my chlorine, and again I've colored my three hydrogens differently so we can keep track of them. And this is the bromide ion coming in. If we spin this model, we can see that the bromide is on one side of the carbon and the chloride is on the other side, and I can line them up just like that if I want to. We know from things that we've seen in class that the Br minus starts to form a bond with this carbon, and the chlorine starts to break the bond from the carbon, so that at our transition state we get something that looks like this, where the bromine has started to form a bond with the carbon, the chlorine starts to break. There's a partial negative on the bromine, a partial negative on the chlorine, and this center here has three hydrogens bonded to it almost in a plane. And we can look at that in our three-dimensional model like this, showing that the bromine starts to get closer to the carbon center. The chlorine starts to get further away from the carbon center like this as the bromine comes in. And we start to form a bond between the bromine and the carbon. This is my partial bond forming, and we start to lose the bond between the carbon and the chlorine. This is my carbon-chlorine bond breaking, and these groups, they were pointed out towards the bromine, they start to move in this direction, so that I end up with something like this in my transition state. And we can spin this around now. You can see that the bromine is coming in, the chlorine is leaving, and that the three hydrogens are in essentially the same plane. That's my transition state. Now, as the reaction continues to proceed past the transition state, this chlorine continues to leave, the bromine continues to come in, and if we look at our 2D models over here, we get something like this, where the bromine is attached, the chloride has left, and the bromine is on the opposite side of the molecule from where the chlorine left from. We can look at our 3D model of this by saying the chlorine continues to move away from the molecule. The bromine continues to come in. These atoms continue going in this direction until this bond finally breaks and this one forms completely, so that we get something that looks like this. Now we can spin this around to see that we still have our tetrahedral structure. The chloride has left. If we compare this over here to our original structure, we can see the bromide pointing in one direction on one of them, the chloride pointing in the other direction on the other one. Now this SN2 reaction happened on a very uncongested center, and that's methyl is about as uncongested as we can get, which is important because in this transition state you'll notice we have 5 things trying to get around this carbon. I want to change the molecule a little bit and make it more congested. I want to change each of these hydrogens to a methyl group. And when I do that and I look at my sort of two-dimensional models, it doesn't look like I changed much, and I really didn't in this model. Everywhere where there was an H, I just typed in a CH3. So CH3, 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 CH3. I've replaced all of my hydrogens with CH3s. When we look at the three-dimensional model, though, we'll definitely notice a big difference. Here's my bromide again, but instead of having methyl chloride, this time I've got T-butyl chloride. And you can see that those methyl groups take up a lot more room around that central carbon than did just having a hydrogen there. And that plays a very big role in this reactivity of this molecule, especially when we go and look at the transition state. Now, in order to draw the transition state, I'll start moving this in because this starts getting closer and it actually starts forming a bond with that carbon. So there's my bond starting to form with that bromine, and at the same time the chlorine starts to elongate and break. So here's my chlorine carbon bond elongating, and finally it's no longer a full bond, and there's my bond for chloride breaking, and now these groups start to move to be coplanar with one another. So I can drag this methyl group like this, and this is not going to be a perfect representation, but it'll be pretty good. And I also want to drag the other one so it's almost in the same plane. So something like this, and this hydrogen probably should be up a little bit like that. And what I want you to notice is that unlike the case with the methyl chloride, this is pretty sterically crowded. Let me move this up a little bit. There's a lot of stuff around this carbon. These hydrogens get pretty close to the bromine coming in and the chlorine leaving, and sterically a lot more crowded. That's why for a tertiary alkyl halide like this one, we don't see an SN2 reaction because this transition state right here, or as shown in 3 dimensions right here, is very crowded. This is going to proceed by a different mechanism, an SN1 mechanism, because this crowded transition state is very high.